All right, the last slope equation we're going to look at is actually from this next section, equations of linear relations, where we're going to take a look at a slope as a rate of change. So the first part, we see a graph shown represents the distance traveled by a car as a linear function of time, where the car is going to be driving a distance in kilometers and a time in hours. If I want to calculate the slope of the line, then I'm going to take the y value of 120 and put the x value of 3 beneath that because they're from the same coordinate. And I'm going to subtract from that the y value at here, which is going to be 40, minus the x value, which is going to be 1. And that's going to give me 80 over 2, which gives me a slope of 40. If I'm talking about rate of change, a change in distance divided by a change in time, all rate of change is doing is it's actually giving us units, which we can see here and here. It was our kilometers and hours. So if I'm going to take my slope and put it into a rate of change, I'm just going to say that the distance is, in this case, because it's got a positive slope, increasing at a rate of 40 kilometers per hour, which means that the two things we need to consider is we always think of rate of change as being a positive value. So we're not going to say like positive or negative 40. We're always going to say it as a positive value. It's just if it actually is positive a slope, we're going to call it increasing. If it's a negative slope, we're going to call it decreasing. And we need to put our units back into our rate of change. If we're looking at another example of this, the graph shown represents the temperature of an oven as a linear function of time, where we can calculate the slope from these 2 points. I'm going to say the slope is going to be represented by 350 over 5 minus that 50 over 0, or 300 over 5, which is going to give me 60. The slope represents the rate of change. A change in temperature divided by a change in time. What units are represented in this rate of change? Well, in this case, we're calling it degrees Fahrenheit per minute. In this case, the temperature is increasing at a rate of 60 degrees Fahrenheit per min. For part 3 here, we can see that for the first time we have a negative slope, so that is going to have an impact on how we describe our rate of change. We're going to calculate the slope the same way. We're going to say m is equal to, we have a 40 on the top over 120 on the bottom, minus 50 on the top, and minus 20 on the bottom. And that's going to give me negative 10 over 100, which would give me negative 1 over 10 as a slope. The slope represents a rate of change, the change in the amount of fuel in the tank divided by a change in distance. What units are represented in this case? Well, the liters of the fuel and the kilometers in distance. Now, complete the following statements. The amount of fuel in the tank is decreasing. The rate of change of the fuel in the tank is going to be negative 1 over 10 liters per kilometer, or the amount of fuel is decreasing at a rate of 0.1 when I actually divide it out into a decimal form, liters per kilometer. If I am determining the equation of this line in the form n is equal to md plus b, well, we actually would have learned that in one of the other lessons here, so I'm just going to tell you that the equation is going to be n is equal to negative 1 over 10 d plus 52. All right, so for example 1, Tyrone is paid a base salary per week plus commission for selling electrical appliances. Last week his sales totaled $3,500 and he earned $620. This week he earned $680 and had a sales of $42.50. On a grid, plot ordered pairs to represent this information. Well, I'm just going to pick 2 points here. It's not going to be exact, but I'm going to state that one of them is going to be at $3,500 in sales, and he earned $620. And I'm going to say that another point is at the $42.50 in sales, and he earned $680. We're going to calculate the slope of a line segment joining these 2 ordered pairs. Well, my slope is going to be represented by 680 over 42.50 minus 620 over 3,500. That's going to give me 60 over 750, which I can call 0.08. Explain what the slope of the line or the slope of the graph represents. He earns 0.08 for every dollar in sales. State as a percent what rate of commission he makes. Well, 0.08 as a percent is going to be 8%, or 8 out of 100. Calculate what his weekly base salary is. Once again, we're going to go over how to do that and then stretch the line back to the point where it gets to 0. But for right now, I'm just going to tell you that it was $340. And how does this answer E relate to the graph? We're going to call it the E-intercept. The equation is going to be E is equal to 0.08 S plus 340. And 2 weeks ago, Tyrone earned $486. Calculate his sales for that week. Well, if 486, which is his earning, is equal to 0.08 S plus 340. First, I'm going to need to subtract 340 from both sides, and I'm going to say that 146 is equal to 0.08 S, and then I'm going to divide both sides by 0.08, and I find that S is going to be 1825. So his sales were $1,825. All right, and the last part. John is taking part in a long-distance car race. After 3 hours, he traveled 270 kilometers. After 6 hours, he traveled 630 kilometers. On a grid, plot ordered pairs to represent this information. Well, first off, I'm going to have to pick how much the units are going to be worth, and I'm going to say that every second line for the x values is going to be worth 1. So I'm going to call this 1, 2, 3, 4, 5, 6, 7. And I'm also going to state that this is going to represent the time in hours. For the y values to make everything fit, I'm going to say that every second line is going to be worth 100, 200, 300, 400, 500, 600, and it's actually going to go up to 650. And I'm going to call this the distance in kilometers. So I need to plot what the points are on the graph, and I'm going to say at 3 hours he traveled 270 kilometers, which is going to be approximately here. After 6 hours, he traveled 630 kilometers, which is going to be about here. I'm going to connect these points. And it wants us to calculate the slope of the line segment for these ordered pairs. Well, my slope is going to be represented by 630 over 6 minus 270 over 3. And that's going to give me 360 over 3, or 120. The slope of the line segment represents the rate of change. A change in distance divided by a change in time. This rate is the average speed between the 2 points. State the average speed of the car from 3 hours to 6 hours using appropriate units. Well, he was traveling at 120 kilometers per hour. Now it wants us to plot on the grid the point of 0, 0. And figure out the average speed of the car during the first 3 hours, so connecting to here. And we can see that it's going to be pretty similar to, but a little bit off of, what the slope is in the second step. The slope for the second step is a little bit steeper, so when I'm solving this, I'm going to say that the slope of the first part is going to be 270 over 3 minus 0 over 0, or 270 over 3, which is going to give me 90. So the average speed of the car during the first 3 hours is going to be 90 kilometers per hour. A little bit slower than the second part. By looking at the grid and without doing calculations, how can we tell that the average speed during the first 3 hours was less than the average speed during the next 3 hours? The slope is a little less steep.